point, up to this, you know, when you were first and second year algebra, a lot of times we use expressions like this. When we solve a problem, we say something like x is greater than or equal to 5. That's called set notation. If we do all that fancy stuff, which I'm not into, I usually just write it this way. But that's called set notation. In calculus, we don't use that kind of notation. In calculus, we use something called interval notation. So this expression, which would look like this if I sketched it on the number line, right? That would be written in a calculus class, and so for us in our class, we will write that like this. Now, the bracket tells me that I have a closed interval. Now what that means is, or a closed dot. The bracket is the symbol for closed dot. What's this the symbol for? Infinity. Does that make sense to you that we're going from 5 to infinity? Infinity is never closed. This is the symbol for open. Since we can't ever get to infinity, since you can't color in infinity's dot, infinity will always be open. The interval notation simply describes a piece of the number line using either a closed notation, which means the point is included, or an open notation, which means it's not. So if I had, if I were solving an inequality and I had an answer that looked like this, I could put that in interval notation by putting a closed bracket at 2 and an open at 6. So interval notation is simply two numbers with a comma in between them, and then you're either using the bracket or the parentheses. So let's do one more. Let's suppose we had x is less than 7. Could you come up with that in interval notation? What do you think that might be in interval notation? We're going to have a 7 and a negative infinity. Would you agree with that? If it helps you to draw it, go ahead and draw it so that you can see, okay, we're going from negative infinity to 7. What kind of symbol am I going to put here, parentheses or brackets? Parentheses on both, exactly. You're exactly right. Good. So if we were to have a little quizzy-poo, and I haven't quite figured out how we're going to do that with these tables, but we'll get that figured out. If we were to have a little quizzy-poo, and I said, write this as a set, meaning like this, as an inequality. Write this as an inequality, would you be able to do it? This is interval notation. Could you translate that into something that looks like this? Oh, I bet you could. What would you write?
Less than x, which is less than 4.
Less than or equal to 4? Exactly. Remember when you write an inequality, kids, and you're describing the region between two numbers, which is what's happening here, remember the symbols are always less thans, always. You're never going to put anything but a less than in an inequality that describes the interval between two numbers. There will always be less than symbols. This one has an or equal to on it because that is a bracket and a closed dot. Okay, so you feel okay about that? Yes?
Okay, what's the difference between the parentheses and the bracket?
Open dot or closed dot?
Okay, so like the, wait, which one's, okay, the parentheses, the open dot?
Yep.
What if they were going the other way?
If they were going the other way, then obviously we don't have an interval between two numbers. So if they were going the other way, that's a great question. Let's say we had something like this. Like that? Got to write it as two separate intervals with a union in between them. So if I were writing this out in an inequality form, I would say x is less than 4 or x is greater than or equal to 5. In interval notation, this would be the interval from negative infinity to 4. This would be the interval from 5 to positive infinity. and then I would use the mathematical symbol for or, which is the union symbol, to link them. Great question, great question. Something like that can never be written as one piece, like this right here. Keep in mind, it's pretty simple. If it's two pieces to graph it, it's going to be two pieces to answer it. If it's one piece to graph it, you can answer it in one piece. All right, anybody else? Good questions. All right, the next thing we need to take a look at then are exponents. We will spend more time with exponents later on, but there are some fundamentals that we need to be able to manage. So let's start simple. Okay, let's say we're going to simplify this. Anybody want to take a stab at it? That's an 8, by the way. Anybody want to take a stab at it? Steinmetz?
Would it be 1/2 x to the negative 1? Wait, don't you subtract the exponents?
In a division problem, you subtract the exponents. Now, another way to think about it though, and that's great, that's the rule. And if that's how you get it, that's how you get it, and that's magnificent. But another way to think about it is, okay, if I look at just the x's, I got 4 x's on the top and 3 x's on the bottom. Who has more, the top or the bottom?
The top.
How many more?
1.
So on the top, you're going to have an x to the first. Now look at the y's. Who has more?
The bottom.
The bottom. How many more does he have? How many more?
3.
3. So I have a y cubed on the bottom, and we're done. Now, I love the fact that you reduce the 5 and the 10. That's exactly what you should do. I didn't put the 1 up here. You can, but, and it would never ever be wrong to do that. It looks a little babyish though. Normally we don't put the 1 in there when we're like grown-up math students, but we can. It doesn't hurt anything. All right, let me make it a little bit tougher. What about something like this? Anybody remember how to deal with that? Somebody say an I? Yeah, I did. Okay, okay. Our wires are a bit crossed, but that's okay. We're going to talk about I's in chapter P. We're going to talk about I's in a few days. When do I's happen? Square root of a negative number. Now, I've got a negative number and I've got a squaring going on, but not a square rooting. There's no I's in this problem. You can only have I's when you square root, or I should say even root, when you take an even root of a negative number. I don't have that. So what do I have here? What am I going to do here?
Don't you make it like 1 over 16?
Okay, now, again, you're right. But again, we can do this kind of the by the book recipe way, which is going to be harder, or we can kind of just use our common sense. The by the book recipe way would say, okay, when you've got something to a negative exponent, it's going to be 1 over that. I don't know about you, I don't like this. This looks hideous to me, right? When you say 1 over, what are you really doing? When you say, like, if you go from 3 to 1 over 3, what are you doing? You're finding the reciprocal, right? Well, if I want to take the reciprocal of a fraction, I really don't want to say 1 over 4 over x squared. What am I going to say instead? What's the reciprocal of that fraction? Exactly. So this is going to be x squared over 4 squared. What does a negative exponent do to a fraction? It turns it over. A negative exponent flips the fraction over. You will get exactly the same answer if you do it this way, but it's just harder. It opens up more opportunities to make mistakes. A negative exponent is going to turn the fraction over every time. When you put a negative exponent on a fraction, it turns it over. Now, we're not done though. What do we end up with here? We're going to square everything, so what do we get? X to the 4th, over
16.
Perfect, beautifully done. beautifully done. Let's try one more. Now my job is to make it as hard on you as I possibly can, so let's look at this. This is kind of a mess. What do you think? There's lots of ways to start. What do you think? What pops into your head?
Flip it.
What'd you say? Ann?
Flip it.
Flip it. Now, you're exactly right. That's how I would start. But when I flip it, I am flipping this exact thing. So on the top, I'm going to have 4y to the 6th, and on the bottom, I'm going to have 2x to the negative 3rd. So I am flipping. This negative flips that fraction. Now I still have a mess to clean up. What do you think about that now? That's a good way to start. You don't have to start that way, but that's a great way to start. What do you think now?
Reduce the 4 and 2.
Oh, that's a good idea, Isaac. We're going to reduce the 4 and the 2. That'll cancel. So now I'll have what?
2y is 6 over x to negative.
Okay. Good. Now again, we've got lots of options here. Miss Gavia?
Multiply each exponent by 3.
So we're going to raise everything to the 3rd power. Now that includes, groupies, the 2, correct? So what am I going to have? I'm going to cube everything now. So what am I going to have? 8 y to the
18.
perfect, beautiful. Now for those of you that have a question about that, remember what cubing means. When I say, 5 cubed, what does that mean? 5 times 5 times 5. So when I say y to the 6th cubed, that means y to the 6 times y to the 6 times y to the 6. How many y's is that? 18, right? Over x to the negative 9. You are not done. You are almost done, but not quite done. One more thing needs to happen. What do you think it is?
The x.
What?
Move it on top.
I got to move this to the top. So my answer, my final answer, is going to be 8y to the 18th, x to the 9th. Do you remember that when you have negative exponents, you move them within the fraction? So since this one's in the denominator, he'll go to the numerator. If he'd been up there, he'd come down. Do you remember that from last year? Good. Good. Okay. All right. That's enough of that. What if I said to you, identify this property? Could you identify those properties for me? Any of them? Do you recognize any of those properties?
5 times 1 equals 5 is the identity property.
Of multiplication, that's right, it's the multiplicative identity. Very, very good. The multiplicative identity, or the identity property of multiplication. It doesn't matter how you say it. That's the identity property. When you multiply by 1, you get back the identical thing. All right, great. Anybody recognize a different one?
Is that this last one, inverse?
This is the multiplicative inverse. When we take the inverse, it's like reciprocaling it, or that's not a word, but you know what I mean. When we multiply by the reciprocal, they cancel out and leave us with 1. That's the multiplicative inverse. Perfect. You guys got it made. I mean, the other two are exactly the same properties, except they're for addition. What would this be?
Additive identity.
Additive inverse. The inverse, look at your inverse property, they cancel each other out. This is the additive inverse. This one is the identity sunshine because when I add 0 to something, I just get the same thing back again. So that's my additive identity. So, suppose I said to you on a little quiz sometime, what is the multiplicative inverse of 2/3? What would you say to me? What's the multiplicative inverse of 2/3? Now remember, this is your inverse property. What do inverses do? When you multiply them, you get 1. Okay, so what would I multiply by 2/3 to get 1? 3. Multiplicative inverse is the same as reciprocal. So your multiplicative inverse would be 3/2. What would your additive inverse be for 2/3? Your additive inverse. Negative 2/3. What's the word for additive inverse? It's the opposite. Multiplicative inverse is the reciprocal, additive inverse is the opposite. So what's the additive inverse of 100? Negative 100. What's the multiplicative inverse of 100? 1 over 100. Very, very good, you've got it. One more property. There are tons of properties, you know that. But there's one more that's specifically discussed in the homework tonight. And it is this property. What property is that? Distributive. Very, very good. Now, be careful because the distributive property works both directions. So in other words, in the homework tonight, they're going to ask you to use the distributive property on something like this. Now, at first glance, you look at that and say, Miss Ford, there's nothing to distribute. Well, because you're supposed to be going the other way. Undistribute it, in other words. So what would we do here if we were going to undistribute this? I heard somebody say, take out. We call that factoring, right? So what would we factor out? A 4, and an X, and a Y. Perfect. Now, be really careful, gang. If you take out a 4X and a Y, you're still supposed to have 2 things left here with a minus in between them. What are you going to have right here if you take out a 4X and a Y?
1.
A 1. Perfect. What are you going to have here? 2X. You guys are amazing. That's awesome. Factoring is the same as the distributive property, just going in the other direction. So be on the lookout for that in tonight's homework. Okay. Now we've got something like this. Your job is going to be to simplify that. What do we call numbers written in this form? What's that called?
Scientific
Good,
notation.
scientific notation. You're comfortable with that. You've all taken chemistry and probably done a zillion of them, so you're good with that. In terms of simplifying this, what would be your strategy? Is this going to be one of those classes where no one talks? It's just not fun. I need you to talk.
Would you, do the tens, like 10 to the 30 times? Like, so it'd be like 10 to the 40.
Well, it would be 10 to the 4th on the bottom, but if my job were to write this as one number, not a fraction, but one number, that would actually be times 10 to the negative 4th, wouldn't it?
Yeah. Just 2 times 10 to the negative 4.
2?
Yeah.
Shall we vote? about that, Isaac? Just think about that for a second. I see where the two's coming from, but which is bigger, 4.5 or 9? So you're canceling and you're getting 2, but that 2 would have to be on the bottom. So instead of 2, maybe what we need is 1/2?
Oh, okay.
Do you move the decimal point?
Yeah. Now, we need to talk about this because that's not, it's right. We haven't made any mistakes. We got it right. But you can't leave your answer that way, can you? Because what did you learn about scientific notation?
The first number has to be between 1 and 9.
1 and 10, actually. The first number has to be between 1 and 10, right? So I'm going to have to move that decimal and turn that into a 5, right? Now, one of the things you're going to get to know about me is I'm old, all right? I do not have much storage capacity up here, and I can't remember anything, seriously. So I have to use my logic here. I don't know, am I supposed to make the exponent bigger, smaller? I don't know, moving right, left, I can't remember all that stuff. But common sense would say, if these two numbers are going to be the same, and I made this one bigger, this got bigger, right? Then what's going to happen to that exponent to keep everything balanced? If the number got bigger, the exponent's going to have to get smaller. So what's the next smaller number from -4? -5. That's it. If you're going to make that adjustment however it makes sense to you, but you're not going to hear Mrs. Ford talk about a bunch of rules about left, right, all that. I can't remember all that. But I know that if I make this part of the number bigger, this part is going to have to get smaller. So if I had something like this, 18 times 10 to the 5th, this is right. So I would have to make this 1.8, right? Well, what did I do here? I made this number smaller so that exponent is going to have to get bigger. Okay? All right. Now, we're going to have some volunteer action. Now, we're going to use all the boards, but if you come to this board today, you will be on tape, so keep that in mind. And I need not everybody, can't fit everybody up here, but I need these 2 tables right here. You work in partners, find a place at the boards, and we're going to practice some problems. I'll put them up, and we will practice them. What do you think those of you sitting at the seats are supposed to be doing right now?
Also working on the problem.
Working on the same problems, that's right. In fact, let's all do the same problem, and then we can compare answers. So here's the problem. Okay, there's the problem. So everybody write it down, everybody get started. Work in pairs. You guys need markers?
So 8x.
Oh, I love watching the school brand new markers. Let's save those for something special.
2x.
All negative 3.
You want to flip it in like the whole thing or flip the numbers inside? Then flip the numbers inside.
First, we have to flip it. I think it
Do we want to do this first?
Doesn't that change the model?
Did you add it?
Yeah, I did the extras. I'm trying
Please compare answers with your neighbor, you guys at the tables.
It's, my homework is posted. I never.
Oh, you,
I mean, so we always have.
or if I got them to multiply the top 16. We're used to the
Experts.
night, I think.
I can't, you have to have that sheet signed by you. Or we.
That's right. I might.
But now they're getting boxed.
But you keep that now. Are you sure this is one? And you wouldn't add those? You would? How is this? Because it's like, like if you flip it, like, if this was positive, you subtract them. So you're still subtracting. Like the aspect.